let's go over to copy with. So now we've done 1, 2, 3, 4, 5 tests. Group copy with. Copy with is going to have an arrange. I don't think we need to arrange anything, do we? We've already got a T model. So now I'm just going to skip that and go to act. T model final result is equal to T model dot copy with. Right, what are we copying with? Let's change the name to Paul. So we're going to expect that the results dot name equals Paul. Or you could even add another expect. We also want to expect that. Oh my days, what's the problem with you? Yeah, whatever. Because I was typing when the test was running, so it's gonna fail. It's gonna fail me. Fail to load outside of a test. I'm so sorry. I keep forgetting about this. Test should return a user model with different data. I'm going to paste that. We're going to expect that's the case. And then finally, we're also going to expect that the results are not equal to. Alright, do you know what? Let's expect that the result no. I have an issue with my test. Failed to load compilation failed for this person. Why would your compilation fail? Expected. Have I made any grave errors? No, I haven't. I don't think I have. Have I? Why would you do that to me? What is the problem? .js utils. Have I imported some? Oh, I've imported something crazy. .javascript library. Alright, so that's it for the model test. Right, so next up, we're going to create our repository implementation. Let's see how that goes. So now in order to create the repository implementation, we are still in the data layer. I'm going to go into the data layer, create a new Dart file, and I'm going to call that the name of our previous repository. Right, so the previous repository in the domain layer was authentication repository. So in here, I'm going to call that one authentication repository implementation. Right, so this one is a contract that defines that every time we want to create a user, we need the creator that, the name, the avatar, and we will always return a future either failure or a void. Right, and this one, whenever we need to get users, we always never take anything in the signature, no argument, right? But then we always return a list of users, right? So this is what we're doing. Now we have to write the implementation of that. So you can see these contracts don't have a body. There's no body in here. It just defines how this should work, how it should look, basically. Sorry, I messed that up. Yes, so that is how that works. Now let me close up these tests. Now the implementation thereof would be a class with the name repository implementation, right? And it will implement the authentication authentication repository, this one. Now in here you can see that it's asking for overrides. So we've written the contract. Now inside of the implementation we have to override the interface that we've created. We have to use, here we go, we have to use polymorphism. I think that's what we're using. We have to use polymorphism and change the behavior of the parent, or we could leave it that way, but we're not leaving it that way because the parent is simply an interface. It doesn't have any functionality to it. So we are going to implement the functionality of the functions. Now, as I already told you, we're basically going to be following the principle D, dependency inversion. Dependency inversion isn't anything scary. It's simply this. So in here, we actually need to talk to the server. When we're creating a user, we need to do maybe http.get request to the server, and then we get the response. Final response will be equal to that, and we can then return JSON decode the response or whatever. This is how the HTTP requests work normally. I know you should have already done some API stuff, right? You should already be familiar with consuming APIs at this point, right? But we're not going to be doing that in here because that is not the function of the repository implementation. The function of the repository implementation is to talk to the data source, right? So the data source will then talk to the external HTTP library or whatever external service we're using, and then it returns that response down to this person. This person in turn takes it back to whoever's calling the repository. So for that to happen, we will need a data source, right? So our data source will be equal to something, a data source. So let's go ahead and create that data source. Data, new. Oh, sorry, I created this in here. We have to create a new folder for this. Call it rep. I usually call them repos, but since it's the tutorial, let me make it full repositories. We push that in there. Then we finally create a new one, new data file, where I'm going to put that in the data sources. It's going to be the authentication remote data source. So it's a remote data source because it's talking to the remote server. If it was speaking to the local server, like the cache on the user's device, then we would say something like local data source. But in this case, it's remote because it's talking to the remote server outside. Now, for this one, we also will create an interface before actually implementing it. So let's go ahead and do that. So we are creating a lot of interfaces. By the end of this lesson, you should be familiar with creating these interfaces. So I'm going to call that authentication remote data source. And I'm going to invoke that abstract class. Then we have our, now remember that in our repository, this one, we were using this functionality where this functional programming functionality where we're either returning a failure or a void. However, in the remote data source, you will only be returning one value, right? So if an error occurs inside of your data source, you throw the error, you throw a custom error. You can throw the error you already have, but for industry standard code, it's best practice to create your own error, your own exception, and then throw that exception, because it helps you define, helps you have more control over the message that you're putting out down to the other layers. So basically what I'm saying is, inside of the remote data source, we do not do either failure or. When there's an error, we will throw that error. If there's no error, we will return the actual value. Now, when there's an error inside of the repository will catch the error that we've thrown, and then return either a failure or the value. So if there was an exception thrown from the remote data source, this person will catch that and then return a failure rather. But if there was no exception thrown, then it will rather return the actual value. So in here, we're not going to do the either or. So what do we have? We have the create user, which takes these three. So we can do that. Create user. Now it takes these three. Let's go ahead and put that there. Now remember that this is a contract because it's an abstract class. It's an interface, right? So we don't need to create a body for it. What does the create user return? It returns either failure or void. In our case, we're returning a void. If there's an issue, we will throw an exception. Let's go ahead and do the same for this person. So we have get users. So for this time, future get users. And it doesn't take any params. So there's no parameters, but there's no parameters, but there's a return type, and the return type is a list of user. Now, instead of doing list of user, we want to do list of user model. Where's my model? I think my computer froze. Oh my. So we want a user model. So this is the catch. In every other layer, we're going to be talking about the core entity. We're talking about the entity. But then in the actual data source, when we get that value, whenever we're returning something, we want to return the model version of it, because later on we're going to be using values like serialization from JSON to JSON. We're going to be using copy with, because our classes are basically final, right? These are final. They can't change. So we need a way to mutate their values, and that is where copy with comes in. So we need these values. We will need these values further down in our UIs when we're changing stuff, when we're sending stuff around. So for that reason, we will need to always remember, in your remote data sources, you don't return the entities, you return the models. This is how it works. However, in the other layers, you do not explicitly state the model, you state the entity. Why is this? Why are we doing this? Why don't we just do, why don't we just do lists user model, since we know we're going to be returning user models along the line? This is because we want it to be as loose as possible, so that if there's another class that implements user, imagine that if we had a different type of user, an admin or something, so inside of user, we had also class admin extends user. Imagine we had that. If we made it to be, if we came here in our remote data source and we made this to be user, if a person was an admin, after we logged in and the server told us they're an admin, how then would you tell your application that this time it's going to be either a user or an admin? That doesn't make any sense. That is bad practice, right? So because we want it to be as loose as possible, this is also another principle of Solid, right? We want it to be basically implementable by anything. So every single interface or every single entity should be able to be subclassed. So we want it to be so open that we can take any class at all, any other subclass of it, and replace this version of it with that subclass. So if we had to return an admin, we can return an admin. If we had to return a normal user, we can return a normal user. So that way we always, in the other layers, always make sure that we're taking the generic entity instead of the actual model implementation of it.